Okay, so we're going to move on to this lesson is called Building the Perfect Square. Um, so, and we actually mean square. I remember when I was learning this, when I say square, I used to think because I was in math class, then they're talking about like squared, but they're actually talking about both a perfect square and a square. Okay, so today you'll be able to find the square of a binomial expression, and you're going to recognize a perfect square trinomial. You're going to be able to create perfect squares from partial areas, and then find the relationship between the terms in the perfect square trinomial. How can we use models to find equivalent expressions for perfect squares? So all of this sounds like, what are you talking about? So just know that your job is to find the perfect square, okay? And so when I say square, I literally mean the shape that's a square, but I also mean like squared. And those two things are talking about the same thing, except for squared, the little symbol exponent, is talking about it in terms of math operation. And then the square actually is talking about like the physical shape, right? So moving on. So this one says, oh, you can't barely see this. Ooh, that's so small. I'm going to read, if you want to read along with me. It says, Optima has a quilt shop where she sells many colorful quilt blocks for people who want to make their own quilts. She has quilt designs that are made so that they can be sized to fit any bed. She bases her design on quilt squares, right, that can vary in size. So she calls the length of each side for the basic square x, and the area of the basic square is the function a of x. So the area with side length x is x squared. In this way, she can customize the designs by making bigger or smaller squares. So first question, if Optima adds 3 inches to the side of the square, what is the area of a square? So I know you're like, wait, what? What are you talking about? So then you build this thing in. And so someone in the chat earlier said, this kind of reminds me of the Punnett squares, or some people call it the heredity box, right? So that is exactly what we're doing here. Okay, those two things are very, very similar. So remember that this is your basic square block, right? And then they asked you to add 3 inches. What is the area of the square? So she goes like this. Here's 1 inch, here's 2 inches, there's 3 inches. And this is what it actually looks like. So what's the area of that square? How do you find the area of a square? So reminding you that the area of a square is length times width, or side squared, right? So let's see what my people did. Yeah, we did this. Very good. So it's going to look like this: x plus 3 quantity squared, right? We're not saying this, right? This is a little different. So 3 squared means that the length of the side of a square is 3. And what you actually did, this person here, 3 squared, you actually found this section here, because that's 9. You guys all see that 9 section there? Oops, I'm on the wrong side. Hold on. So that's actually the 9 right here, right? This all makes up the 9, right? So we actually want to write it like this: x plus 3 quantity, meaning in parentheses, squared. Okay. And for those of you who haven't seen this yet, like one more time, when you're putting this in here, choose a little math button, and then you could put it like this with your symbols: x plus 3 quantity. And then to the is the little caret symbol. It's shift 6 squared. So make sure that you know how to do this, because remember, we will be testing you on, or I'll be testing you on your accurate way of representing it. And so I've given you an opportunity to learn it. And so now I'm going to be a little bit more grading, a little bit more strict on making sure that you guys have that down. So so we have x plus 3, and you want to put the squared right here. Whoever Sophie Germain is, you need to put it there. This looks good. I want you to try, whoever Christina Eubanks Turner is, can you try pushing the math button? This looks good. 6 is not the right answer. Not the right answer at all. It wouldn't be 6. And in fact, I understand what you're talking about in terms of 6. There are 6 things here, but this right here would represent a different, it's not just 6, right? Because this is 9 square units right here. So my answer here is going to be x plus 3 quantity squared. Okay. So the next little guy says, okay, so when optimal draws a pattern, it looks like this, right? Use both the diagram and the equation a of x equals to x plus 3 quantity squared to explain why the area of the box is x squared plus 6x plus 9. Okay, let's pause a second. So this is the big area. That's x plus 3 quantity squared. But then we also have this x squared plus 6x plus 9. So on your diagram, I want you to label, see how I wrote 9 here? I want you to label, where do you see the x squareds? Where do you see 6x? Okay, I'm going to pause and see what you guys have so far. So go ahead and put that out there. All right, so my task for you was to label where all these pieces are, x squared plus 6x plus 9. And I have a bunch of people who's done this really, really well. I'm going to choose this person just because it's so color-coded nicely. Does everybody see the x squared? And that makes sense, right? Because look, x times x is x squared. Very good, x squared. And then you have 6 x's. Well, that makes sense because 3 times x is 3x. And then x times 3 is 3x. Very good. And 3x plus 3x is 6x. Very good. And then these little 9 guys right here. 9 right here. Oh, up here. If you want to change colors, it's right here. Oh, you got it. Very good. And then you can also change how thick you want it to. Very good. So this is exactly what it is. So I'm just going to copy that person, make sure that I have it on my notes for you all. So this is x squared. I'm going to write this as 3x. Hopefully you guys are okay with me on there. I do really like the colors and it shows off really nicely what they did. I'll choose different colors just because these are reminding me of algebra tiles, and algebra tiles kind of look like this. I think this is yellow down here. And I think that's blue, and I think this is green. Hold on a second. This is green. So these are green over here. When I do this, I tend to go really quickly, and so I don't draw these rectangles perfectly too when I do it real quick. Very good. So awesome work there. Thank you for being so colorful. It makes it easy to understand for your classmates. Okay, so the next little slide says the customer service representative at Optimus Shop works with customers and writes up the orders based on the area of fabric needed. That makes sense. As you can see from problem 2, there are 2 ways that customers can call in and describe their area block, quilts. So one of the ways is this. I'm just going to make it really, really big so it's very obvious. One of the ways is this, x plus 3 quantity squared, and the other way was x squared plus 6x plus 9. Now, I know that these 2 expressions look really different, okay, but it's kind of like this. It's like, you know, you might have a nickname and that's one of your nicknames, but then here's your formal name. Or some people call me Mrs. Johnson, right? And then my children call me mom, right? So does that make sense? Like, even though I have 2 different names, I'm still the same person. It still equals me, right? So same thing goes with you. Even though these look really, really different, it's still the same value. It still represents the same thing, right? X plus 3 quantity squared means this times this is equal to x squared plus 6x plus 9, right? The other thing that I want to keep in mind as well is like, when you see things that look different but are the same, it's almost like a $20 bill versus 4 or $5 bills, right? Okay, so let's continue. One way to describe the length of the sides, and the other way is the areas of each of the 4 sections of the block here. 1, 2, 3, 4. Then it says, for each of the following quilt blocks, draw the diagram of the block and write 2 equivalent expressions or equations for the area of that block with side x plus 2. So when I draw this, I don't draw such a neat little rectangle. So if yours doesn't look perfect and neat, that's okay, not a big deal. So let's see what your classmates did. So this, Yeah, this looks good. Okay, so the only thing I would correct on this person's, so person go and correct this because as I write it on here, it's not going to make sense. X times X is X squared, right? X times X is X squared. And 2 times X is 2X. So not each of these being 2X, but these two together make a 2X. Can you fix this, person? Very good. Your answer is perfect. This is perfect. But your representation is a little bit needy. And then this is 4. That's perfect. So go ahead and take care of that. I'm going to pause this really quick. All right, so very good. So the very next thing that I want to show you is how I draw it, kind of like shorthand. So when I draw it shorthand, it says X plus 2. So first I draw a side with length X plus 2. And then I draw another side with length X plus 2. And again, I'm going to try to make this as squarey as possible. But again, I'm freehanding this, so it's going to look the way it looks. So then when I draw this in, to make it look as squarey as possible. And as soon as this guy catches up to me, hold on. Oops, just kidding. All right, there it goes. So then it goes like that. And then, so then I start drawing where my pluses are. That's where I start dividing it. So here's where one of my pluses are. And then here's where my other plus is, right? And so if you look, this is X squared. Right? And then here's my 2 X's. This is my 2 X's. And this is 4. So I'm going to write it as X plus 2 quantity squared is equal to X squared plus 4 X's. See, 1, 2, 3, 4 X's plus 4 plus 4. Okay. So this is how I do it if I'm taking my time to actually build a square. I'm going to show you how I do it in shorthand really quick for X plus 1. For X plus 1, I do the same thing. So I'm going to draw this one over here just so you can see it better. So if it's X plus 1, I still do X and I still do plus 1. And I still do X and I still do plus 1. Except for here, when I draw my little squares, so I draw a square for X squared. And then my plus 1, I just draw a stick just to make it a little bit faster for me to draw. You could do the same thing because it's hard. I get it. It's hard to annotate on here, right? And it's not going to show up. You're so cute. Very good. Absolutely. You should feel very strong about your work, even if it's not perfectly right. Oh, there it goes. There it goes. So this is how I draw shorthand. Okay. So this is X plus 1 going across. And this is X plus 1 going down. So this is still X squared here. This is still X squared. But do you see how this is like a little stick instead of a rectangle? It's just going to take me a little bit shorter to draw. So I would still draw it this way. And then I do a little plus sign here because it's positive 1, 1, positive 1, right? Do you see my rectangle? Still a square. So I don't care which way you do it. I'm just trying to give you an option to draw it a tad bit quicker. Okay. So this expression is X plus 1 quantity squared is equal to X squared. Is my X squared? How many X's do I have? How many X's do I have for X plus 1? Sorry, let me get to the right. How many X's do I have here altogether? Yeah, I have 2 X's. So I write plus 2X, right? And so some people say, Ms. Johnson, how come it's 2X? Well, like if I had a puppy and then I had another puppy, you all would say, Ms. Johnson, you have 2 puppies, 2 puppies. Here I have an X plus an X makes 2X. So I'll just put a little X here so you guys all know that that's my X, right? And then I have plus 1 because that's a 1, right? Now, some of you are noticing, oh man, Ms. Johnson, I noticed that X times X is X squared. Exactly. X times 1 is X. Exactly. X times 1 is X. Exactly. And 1 times 1 is 1. Exactly. That's exactly what I wanted you to find. So your brain should be like, hey, what other patterns do I see? So that's actually question number 5 for you. It says, what patterns do you see that relate to the diagrams between the two expressions? So I'm going to make you stare at these two expressions that I have here. I know they're drawn differently, but just pretend. What do you see here? What patterns do you see? Yeah, very good. Someone said, Miss Johnson, I noticed that it's blank squared. Exactly. I see this squared. Let me make this big. I see this squared, Miss Johnson, and I see this being squared. Very good. What else do you guys see? What else do you see? Either tell me in the chat or put your answers up here. It's fine. Yep. Man, hey, Miss Johnson, I still see these x squareds everywhere. I see x squared here, and I see x squared here. Now, you could have been saying, Miss Johnson, I see the square, the x squared here, or the x squared here, but it matches, right? Very good. Thank you for sharing that. Anybody else see anything else that they notice? Anybody see anything else that they notice here? No? Okay. If you do notice something, tell me and I'll bring it back. Okay, the next one. It says Optima, let me make this a tad bit bigger. It says Optima likes to have her little dog Clementine around the shop. One day, Clementine got a little hungry and started to chew up the orders. Dun, dun, dun. When Optima found the orders, one of them was so chewed up that there were only partial expressions for each of the remaining areas. Ah! Help Optima by completing each of the following expressions for the area so that they describe a perfect square. Then write the two equivalent expressions for the area of the square. So wait, what do you want us to do? Okay, let me show you. So here for this one, right? For this one, it's really, really small here, so I'm probably not going to do it. So what I wanted you to do is I want you to grab an x squared. So that looks like this, right? And then you have 4 x's. But now you need to rearrange the 4 x's so that it'll eventually become a square. So if you've been noticing, I've been placing x's here and across this way. So can you help me? Where should I put some of these x's? If there's 4 x's, how many x's do you want me to put on this side? Yeah, I need 2 of them. Very good. So I'm going to put 2 x's here, just the way I do it. 1, 2. Oh, but where do you want me to put the other 2 x's? Because there's 4 altogether. Where do you want me to put those other 2 x's? Oh, on the bottom. Exactly. So go ahead and put 2 of them on the bottom for me. Go ahead. Put 1, 2. Okay. So then how many would fit here? How many little ones would fit here? Now, if you're just learning this, I would not suggest you to do it my shorthand. So I'm actually going to redraw this one, and I'm going to draw it the box, the square way. So here's my square, right? And then here's my x squared. And then here's my 2 x's that you said here. And here's my 2 x's that you said here. Oops, those don't look very xy, but that's okay. So 2x, right? So my question is how many ones are going to go here? How many ones are going to go there? Oh, 4? Where'd you get 4 from? Wait, where'd you get 4 from? A bunch of people just told me 4. Wait, how did you get 4? Where, I mean, like, why does that make sense? Oh, because 2 times 2. Like, can you guys all see this? Like, if I draw this in like this, if I continue this guy right here, do you all see how there's 4 of them? Like, wait, hold on, it's coming. It's gonna come, right? Sometime soon, it's gonna show there. So do you all see where the little thing is here? The little 4 right here. See how if I pull this guy down and I pull this guy down, how it's 4 of them? You guys all see that? Oh, so the missing little part for this guy was going to be that +4. Does that make sense? Okay, but they also wanted you to write the 2 equivalent equations. So wait, you want me to write that thing with the parentheses squared, Miss Johnson? Exactly. Okay, so the very first thing that I did, and you can't see it because my thing is really slow. The very first thing I did is I added a 2 here. So let me erase this stuff here so you can see what I did. So the very first thing that I want to do is I want to put a 2 here. Plus 4, right? That's one thing that I want to do. I want to put a +4, just like I did there. Yay, it's showing up. Right? So then I put the plus little 4. Do you see how I kind of pull these guys across and that's why it's 4? Does everybody see my +4? Good, thank you. Okay, now the last little piece, and then I'm going to let you try these 3 on your own. The last little piece is, okay, well, what would go in here? How long is this side? 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 What do you guys think? What can I put there? Someone put x plus 2. X plus 2. Someone put this in the chat. They said x plus 2 quantity squared. Let me show you what they put. They actually put a lot more, but I'm going to snip it right now. Someone put this. Does this make sense to you? Someone put, and I'll put it right here so that you guys can see everything. Someone put this in the chat. They said x plus 2, oops, sorry. X plus 2 quantity squared because, and it belongs with x squared plus 4x plus 4. Does that make sense? Someone's asking this. Ms. Johnson, does that make sense? Yeah, right? Because this looks like x plus 2. This looks like x plus 2. You guys all see that? And plus, hey, Ms. Johnson, I don't know if you remember, but that's exactly the one that we did up here. Yes, that's right. So in math, it's pretty classic. You're going to go forwards and then you're going to go backwards. You're going to go forwards and you're going to go backwards. Okay. So with that being said, can you try these 3? I'm going to pause the video. I want you to try these 3 on your own. Okay. Go ahead and pause the video. Okay. So I asked if you can finish these 3. I'm just going to move on to the next one. So I'm still going to draw it just because I think that helps a little bit. So there's 2 things that I'm looking for. I'm looking for the number that fits right here. And then I'm going to look for what's the expression that that's equal to. So I'm looking for the number that fits right here and then what expression that equals to. So when I draw x squared plus 6, it's going to look like this, right? X squared plus 6x. Now here's my x squared, right? Yeah. Oh, it's slow. How many, like if this is my little square, there it is. If this is my little square, how many x's should I put on each side? Oh, really? How many should I put here? Now someone said 2. I'm going to go with 2 just so that we can look at 2. So if I put 2 here, right? Then how many would have to go here? Because altogether I have 6. I have 2 here. How many are going to go here? Yeah, it can't be 2 and 2 because that's only 4. It needs to be a total of 6, right? Yeah, it's got to be 3 and 3. Very good, very good. So who cares if you're wrong? Let's just not stay wrong, right? Okay, so that's 3 and 3. So here's my 3x's here and 3x's here. Do you guys all see the little part that's here that I'm missing? Do you all see this little part here that I'm missing? How many is going to go in there? 9 is correct, right? Because I've got 3. Can you kind of see the square being built? It's 3 here and 3 here. So this is going to be 9 altogether. It's me like trying to make a little thing there. Does that make sense? Very good. Very good. And if you got it wrong, who cares? You got it wrong. Just move forward. Okay. So with that being said, now you want to kind of consider like, okay, what patterns am I seeing? What pattern am I seeing? So here, if you look at this one, right? You told me put 2 X's here and 2 X's here. Here, you told me put 3 X's here and 3 X's here. What patterns are you now seeing? Yeah, good job. So, okay. So what pattern are you seeing in terms of where I put my X's? Do you guys see this? What pattern are you seeing of where I put my X's? I had to put 2 here and 2 here. And I put 3 here and 3 here. Yes, the number is increasing, but how do I know how many to put here? Like for this 8x, how many am I gonna put here? Okay, very good. Someone said, hey, Ms. Johnson, is this x plus 3 on this side right here? Is this x plus 3 here? Yeah, it's x plus 3. Good. And x plus 3. Ooh, someone said, I think for if it's 8x, I gotta find my thing. I think if it's 8x, then we just divide by 2, Miss Johnson. So someone just said this. This is pretty fantastic. This is like one of those key little pieces. So you just divided by 2? Wait, let's try that. If we had 4 x's, oh yeah, it was 2x plus 2x. And for 6 x's, it would be 3x and 3x. Oh, so if it's 8 x's, you're saying I'm going to put 4 on each side? Oh. Try it. Let's try that. Okay. So I'm going to go right here and build my square. So here's my x squared. So how many do you want me to put here and here? How many would you like me to put here? Oh, 4. Okay, so 1, 2, 3, 4. That's 4 x's, right? I should do it a different color. Right? So that's 4 x's. And how many do you want me to put down here? Yeah. Good. Okay. So notice here when I go this way, I go they lay down this way. So then I get 4 x's this way. So how many would be in here? Ooh, 16. How did you get that so fast? 16. How did you get that so fast? How did you get that so fast? Hey. Start answering questions. We lost you. Oh, 4 times 4. Oh, because there's 4 here and 4 here. Okay, then fine. The last little piece is what's missing in here. What's missing in this parentheses squared? How would you write that? All right, I've lost a couple people. Come on, y'all, come back. Come back. Oh, is that what it is? Can you put your answer in the chat as if this was the quiz? Okay, I got 2 people who have it right. You got it right and you got it right. Good job. Yes, just squared, right? Very good. Very good. Not for this one. For this one, it's not going to be x plus 3. Yeah, very good. It's x plus 4. So this one's going to be x plus 4 squared. Okay, don't lose attention right now. This is not the time. This is like that key part in the movie, right? That if you don't pay attention right here, the rest of the movie won't make sense. Okay. So here we got x plus 4. and x plus 4. Very good. Done. Okay. If you really understand this, you may not need a diagram. If you really understand this, you may not need a diagram for this last problem. So can you try that on your own? What number would go in all of these little spots? I already know this is going to be x plus something. I already know that. What? Wait, did you just do that without any diagram? Ooh, I'm so excited. Very good. Very good. So again, so when people sometimes math gets a bad rap. Oh, are they gonna, have to draw these pictures forever? No. This is the equivalent of like when you were a little kid and you were counting things, counting candies or counting pennies. You don't still count pennies, right? Or this is equivalent when you were first learning multiplication tables and you're like 5, 10, 15, 20, 25. The answer is 25, right? So eventually you won't need this, and then you'll just do this because all that work is happening like visually in your brain almost. Does that make sense? I've got 1, 2, 3, 4, 5, 6 people with the right answer. Awesome. So I need a couple more people. I'm going to mark down your participation while I'm writing this to give you a couple more seconds to try to get this answer right and in. Again, your whole deal is to try to make sure that you understand this before, sorry, that's a little dramatic, I know, before you take your quiz, because then it just makes more sense. All right, so someone said, Miss Johnson, okay, so in what order do you do this? Because I do this differently, and I'm curious. What number did you fill out first? This one here or this one here? I'm curious. Did you fill out, like when you were figuring this out, did your brain figure out these guys first or this guy first? Oh yeah, I did too. So I figured this one out too. Okay, very cute. Okay, so most people said, hey, Ms. Johnson, this is x plus 6. And if you don't know why it's 6, look at my friend over here. He told us why. So this is a 6. And then they figured out this number. But how do you get this number? What do you do to get this number? Yeah, you multiplied it, right? 6 times 6. So this one was 4 times 4. This one's 3 times 3, so on and so forth. Very good. Very good. Okay, so I've got a bunch of people knowing how to do this. So this is going to be 36, also known as 6 times 6. Just a little note to you. Okay, pretty much done. It says x squared, if x squared plus bx plus c is a perfect square, what is the relationship between b and c? What is the relationship between 8 and 16? What's the relationship between 4 and 4? Yeah, me too. Good job. What's the relationship between 6x and 9, or just the 6? And it's basically what you guys like kind of talked about here. So first, I want to put this here, right? Yeah, they do have common factors. I agree with that. Very good noticing. So the first thing I want to say is the b is divided by 2. So here I'm going to put this b is divided by 2, right? So when you take b and divide it by 2, that's so, and for example, this is 8 divided by 2, which is 4. What did you do to the 4 to get 16? What did you do to that 4 to get to the 16? What did you do to that 4 to get to the 16? Yeah, you squared it. Very good. Very, very good. Yeah, you squared it. You multiplied it by itself. However you talk about it. Yeah. So here, that's what we want to say. The relationship between B and C is when you take half of that, divided by 2, and then you square it, that's how you get C. Okay. You guys now know how to do this and this. Okay, so here's a different question. What would happen? Okay, now remember, we're building a quilt here. What if the B is an odd number? Would it still work? Would it still work? And the answer is yes. You would just have a fraction as the answer. Yeah. So we're gonna think about that later on. But one more new customer representative thinks that she doesn't need to draw the diagrams anymore because she found the shortcut. She writes x plus 5 squared is the same as x squared plus 25. Do you think she's right? Do you think she's right? X plus 5 squared. And if you don't know, use the diagram. Hint, hint. If you don't know, you can use a diagram. Try that. See if that's true. So what would go in this little area right here? What would this one be? Yeah, x squared, very good. Okay. What would go in this little area here? Yeah. What would go in this little area here? Yep. What would go in this little area here? Very good. Very good. Okay. Got a bunch of you on point. Oh, is it different? Oh, okay, yeah, this needs to be fixed. 25, sorry. This needs to be a 25. So can you look at this one? Thank you for telling me that. Okay, let's see if this is true. And we can also check the other one if it's true. So look, is this the same as this? Is this, thank you, the same as this? So can you write this out for me? So I see x plus 5 squared. So add this up with me. I have x squared, right? Right? I have x squared. And then I have 5x plus 5x. What's 5x plus 5x? Yeah, it's 10x. And then I have this 25. So plus 25. So my question is this the same as this? Is this the same as this? Are these two the same? So say this with me, x squared plus 25. Is that the same as x squared plus 10x plus 25? Does it say the same thing? Yeah, this doesn't say the same thing. So is her shortcut good? No, her shortcut is not. Yeah, it is trash. Yeah, this is not good at all. So students like to do these shortcuts like in my class, and they think that it's right. Now, there are certain shortcuts that make sense, but this one will give you a wrong answer every day of the week. Okay, so don't do this. Very good. Good job. All right, stop